In this video lesson, we're going to talk about lateral movement with the local administrator account. Although we're going to focus on the local administrator account, this really is an issue that will exist with all local accounts that have the same password set across multiple devices. We're going to focus on the local administrator account simply because this is the most common case and because this account actually exists in all environments by default that have an enterprise version of Windows. So what is the problem? The problem is that an account ends up having the same password stored across all workstations and potentially across all servers. I've seen a common approach where workstations might have one password and servers might have a different password, but all servers will have one password across all of them, and all workstations is going to be just a different one. And that is not really fixing the issue. And so the main issue here comes is that if you compromise one workstation, take workstations for example, let's assume that the same password is used across workstations and servers for simplicity to understand the problem here. If we compromise one workstation, or if an attacker compromises one workstation and gains administrative privileges on that workstation, they will have the ability to extract the password hash of the account called administrator, because password hashes of local accounts are stored in the registry hive on the local machine. So compromising one machine gives access, compromising one machine, escalating to administrative rights will give you access to go and extract this password hash. Now, in many organizations, the escalation part is probably not going to be needed because many users run as administrators by default. And that is a massive mistake as well. You should not let your normal users have direct administrative rights. If they need to do that, there's many solutions that you can use instead, which will elevate you for 1 minute, for 5 minutes, or some custom time span that you might like to set for your environment. Or you can even provision a second administrative account where users, if they're required to be administrators for one reason or another, they need to log into their second administrative account and use that one to perform administrative tasks, but not do it with the normal account that they use on daily basis. They read emails, they read the internet, and so on. So the issue with the password hash that you can extract here is that, well, the first one is obvious. You can go and try to break that password hash. You can use password cracking tools such as Hashcat or John the Ripper, that you can go try to crack the password hash and get the plain text password of that hash. If you have the plain text password, you can connect remotely to other machines. But the caveat here is that you actually don't need the plain text password to connect remotely to other machines. You can use the password hash as is, and that is technique known as pass the hash. So you can, by compromising one workstation, in theory, and extracting the password hash from the registry hive, in theory you can connect to any other system in your environment. And that sounds absolutely crazy, because compromising someone in any department, let's bring up HR, because HR are people who are normally targeted in targeted phishing attempts, and they're probably also my favorite when we're doing red teaming engagements. If you compromise an HR person, that person's device will give you access to the rest of the environment. And of course, we should not have this. The exposure is too massive. We can't have one device being single point of failure, and definitely not just a regular workstation. So here's an example how we can abuse this. We are running we're running on a machine called VS10001. I'm assuming this stands for workstation 10, referring to Windows 10 001. The next step is we're downloading Mimikatz, or the PowerShell version of Mimikatz called invoke Mimikatz, into memory, and then executing a custom command, LSA dump SAM. This custom command will locate the registry hives on the computer and extract the password hash of the all local accounts that it detects. And in this case, what I have highlighted is the password hash of the account administrator. It's really that simple. Getting a tool such as Mimikatz, running it, and then you have the password hash. And if anyone is not familiar with Mimikatz, this is probably the most common hacking tool, which I'm just assuming that everyone is familiar these days with. But other than this capability, it became really famous because of its ability to extract plain text passwords directly from the memory of the computer. Or essentially, these passwords are stored into the process LSAS that Mimikatz debugs and locates, extracts, and then gives to an attacker. But in our case, we're getting the hashes. Now we have these hashes. They're available to us. We can point them to any other system and authenticate to it as the account local administrator. And why would we do that? Well, first we want to, or not we, but an attacker would want to go and identify what files and data is stored in those systems. But potentially they'll also want to perform or utilize Mimikatz again, especially on servers, and try to extract more privileged credentials from those servers. And most likely the credentials that they will be looking for are those of domain administrators. And of course, that is really bad because from one system, you might end up into a position to move lateral across, sorry about that, lateral across your environment and essentially perform credential theft to obtain credentials of higher privileged users such as domain admins. So here's an example of using a tool called CropMapExec, where we're specifying the user administrator and the password hash that we have just obtained. The X parameter specifies the command that we want to execute. In this case is hostname. We just want to run hostname. Then we're specifying that we want to authenticate with the local user towards the remote server, so that this is the administrator account that is local to the system and not the account administrator that is part of the domain. And what we can see here is that the tools, one of the messages that comes to us in a different color is punt, which identifies or outlines that we have successfully connected remotely to this machine, and we executed the command returned server 01. So we actually successfully connected to server 01 with the account administrator and executed this hostname command, which returned server 01 back to us. Well, there are multiple solutions to this issue. Some of us, or some of you, might simply disable the account called administrator because it's not being used. But one of the concepts that we're going to be discussing in a future video is Active Directory tiering. And if we implement the tiering model, this local administrator is going to be extremely handy to prevent credential theft in our environment. But what we want to achieve with this account administrator is that we want it to have a unique password for each device. So, and some of you might have already created some scripts that could perform this. Microsoft came up with a solution, which is a tool called LAPS. It stands for Local Administrator Password Solution, and it can set the password uniquely for each device in the entire Active Directory, and it will manage the password by occasionally setting it to a unique value on a predefined time base by you. It will change and rotate the password on an ongoing basis. Normally, I would recommend this to be on daily basis because there's no reason really to keep the password for more than 1 day, and 1 day is the minimum. So yeah, LAPS is one of those really good solutions in this case. It's very easy to implement. It does require a change into the Active Directory schema because the password that each computer is going to have set to its administrator account is going to be set actually in Active Directory. So what LAPS is going to do is it will create a new attribute for each computer object and then store the password inside there. By default, only domain administrators will be able to read this password, but you'll be free and able to perform any kind of delegations you like to give, for example, service desk or any other personnel of interest access to read these passwords as well.